Dr. Siddhalinga is here with us. Achha, Dr. Siddhalinga is here with us. If you can please allow him the access. Welcome, Doctor. Um, Welcome to the consortium. Hello.
Hello.
Good evening, Dr. Siddhalinga.
Good evening. Good evening, madam.
Good evening, sir. So, sir, in a minute or so, we will be starting it off.
Okay. So you need still some more time?
Or we are good to go. I guess we are on live, right?
16 participants have joined. If you want to.
So, sir, this is the organizing team. We have not shared the Zoom link to other participants. Only organizing team will be here, and the rest will be joining us through YouTube Live.
Okay, YouTube Live, the people are joining. Okay. So let me know when you want to start. Okay. So we can start on that moment itself. So I can wait for 1 or 2 minutes if you want YouTubers to join there.
Yeah, sure.
Yes.
On your go. Good evening, one and all. Welcome back to yet another exciting session. I'm Saharsh, and I'm here today representing CheckDit. CheckDit, along with its collaborators, ACM, LMN, IIT Jaipur, Heartfulness Organization, BMSCE College of Engineering Bangalore, ESAIL, IIT Mandi, IEEE BMSCE, CodeChef, Microsoft Innovations Club, Music Club, Dance Club, Dramatics Club, VIT Chennai, Skillenta, Ojasvi LPU, and Affinity Branding, along with our sponsors, Verivo Motors and EduCheck, brings to you the first ever International Research Consortium, an extravagant event with illuminating panel discussions, enlightening and knowledgeable speeches from various speakers, reputed speakers from across the globe. And of course, an ocean of opportunities for you in front of networking sessions, ideathon, competitions, and research expo. Connecting the minds of tomorrow to the experience of today. With this particular tagline, dear attendees, CheckDit brings to you its mega internship program from where you can gain insight into the real world. For more info, please head out to our website. Also note that you must fill in the feedback form for your attendance in the consortium. Now, without any further ado, let's invite our esteemed speaker for this particular session, Dr. Siddhalinga Uralagin. He is an assistant professor at BITS Pilani, an MIT graduate. Dr. Siddaling is an expert in machine learning, data science, data mining, neural networks, deep learning, NLP, text mining, image recognition. With around 54 international research publications to his credit, he is involved in developing data science projects which are applied to the real world applications. He believes that to enjoy anything in this world, one must earn it first. Amazing thought, sir. So with that particular thing, sir, I will open the floor for you. So, sir, stage is all yours. Please guide us ahead.
Yes, thank you, Saresh, for a very nice introduction. I'm very happy to see that such an initiation is taken by the student organizing team, especially when it is highly required nowadays that pandemic time, and students need to be get motivated, and they need to have a channelize their energies towards their developing the careers. So this is a very high time that you organizers have decided to take up such an very good initiative, and I hope all the success for this particular initiation. So with this Saresh introduction, I will start today's presentation on one of our paper. Also, I will show you the starting from the very basics towards how it can be some ultra very good results can be obtained with the help of some of the work what we have done in BITS Pilani. So I want to share my screen so that I can show the presentation. With the presentation, I am ready to show some kind of explanation and the results. So let me see that I can do the can share. Yes. So yeah, I think screen sharing is on. I think you are able to see the screen share.
Yes, sir. If
Yes,
you may
and
go
my
to the
voice
full
is
screen mode, sir, if you would
full
like.
screen. Yes, and I hope you are able to hear my voice clearly. There is no technical issues as such. So today's topic is introduction to deep learning and integration. So most of the thing what we are seeing nowadays, the advancement that is taking place in deep learning, and moreover that the people are looking forward for integration with the other techniques in order to enhance their capabilities to the next level. So this is one of the work that we have published in Elsewhere Energy. The impact factor for this journal is 7.14, and highly impact journal. The idea of how we come up with an integration and what is the best we have achieved after the integration. So overall presentation will be resolved around towards the understanding of deep learning, what is LSTM, what is recurrent, and how you can make it better by using different integration techniques. So that's the overall idea. So this is paper is well worked with the three authors. Myself as a first one, Nikhil Sharma is my UG student. He's a brilliant student. He's now currently studying in US. And one more professor from BITS Pilani, TK Datta sir. So three of us, we worked on the principle and then made it publication available. Now, the highlight of this presentation is understanding what it is deep learning, what are the differences between DL, ML, and AI, because we are hearing these keywords many times, and sometimes these are overlapping. We may get confused. What is DL? What is the difference between ML, and so on? We will see some insight about that, and various approaches that are present in the DL also we will see, and some of the architectures, and deeply we will go into some of the known architectures that are present in convolution neural network, and then we will shift ourselves towards the recurrent neural network and Mahalanobis distance, because we have integrated Mahalanobis distance with the LSTM. LSTM is one of the next level recurrent neural networks. Thereby, we will look into the various aspects of these deep learning, starting with a very simple one. What it is deep learning, because I want to take from the initial level where what it is meant by deep learning, and gradually increasing its higher level, going towards the architecture and so on till towards the integration. So that's the overall objective of this today's presentation. So deep learning is basically derived from the earlier work of artificial neural network. Artificial neural network, you all know that is it is been inspired by the human, how the human brain works. Okay, so the basic understanding is taken from the human brain, and then they simulated the same mathematical model in terms of the computation world. So that's the main idea of deep learning, sorry, artificial neural network. Next level is deep learning, is again derived from the artificial neural network. It is an advancement techniques that are applied on the deep learning, and their capabilities have been enhanced multifold, and their capabilities of learning also increase. So many people give different type of uh, definitions for the deep learning. So this is again a subfield of machine learning, and again it is been inspired by the earlier work of artificial neural network. And let me see, yes, and various type of models which are present in deep learning. We can see that there is a convolution neural network. These are some of the main and mostly used for the practical application. Recurrent neural network, denoising autoencoder, this is also very interesting type of neural network. Deep belief neural network, again having a different features which are not present in the convolution or a regular artificial neural network. And long short-term memory, that is also short, in short it is called an LSTM architecture for the deep learning. So there are different architecture and the models which are present in the deep learning, and having different applications. So where you will use denoising autoencoder is totally different area, and where you will use LSTM will be on the other totally different type of area. So based on the requirement and the application what you are looking at, different type of algorithms and models have been used. Now various type of application you are seeing now, if you take a look at it, what you can do with a deep learning or the neural network, you can use a simplest application to be built in the Android and deploy it in your mobile to recognize your face. So face can be recognized. Now one of the best example that identifying the lip movement, so you can see that lip movement can be detected in a practical sense, and that can be part of your camera, and the camera will detect that whether the person is moving his lip, and then based on the smile, then the selfie can be taken. So this is a kind of application, or you can say penetration, that it is happening with the help of artificial neural network, artificial intelligence, and more like a machine learning areas. There are a lot of standard applications you can see. One such is the computer vision. In the computer vision, you are mostly interested in applying both the cameras as well as the learning capabilities of artificial intelligence, and various applications such as identifying the number plate. That is a very good example, where whenever the person speed up on a road, then you want to capture his speed and identify their numbers, etc. That can be done with the help of the computer vision. And automatic or robot identify the path identification. So these are the another example of computer vision. And coming back to the drug design, nowadays people are moving from the generalized drug towards the personalized drug level, in the sense that you will identify the most required properties to be part of the drug. That you can do with the help of bioinformatics, understand the characteristic genome sequence of a person, and then that can be utilized in order to create the next level drug, that is more personalized level of drug. So that is possible with the help of, again, artificial intelligence and these newest techniques. And text mining and speech recognition, you must have already used various Google based voice assistants, or Apple voice assistants, as well as Alexa, which is again Amazon based voice assistants. So these are some of the techniques which both use natural language processing, understanding the voice, recognize that, and provide the assistance based on the whatever the feedback that it is taking place. So you can see that it is penetrating at the higher level. As we proceed further on, you will see further more penetration happening, these artificial intelligence coming every day into your life. So that's how it is going to change the current world into the much better and much sophisticated way of living in further years. So coming back to the very fundamental question, what is the difference between AI? because most of the time we will hear about these words, AI, ML, and DL. Okay, so these are the different terms that short forms of artificial intelligence, machine learning, and deep learning. So these are some of the words what we usually hear. But most of the time we will also see that several techniques which are part of artificial intelligence, they are also coming in the machine learning, they are also coming in the deep learning, and we will see some kind of overlap. So many times we will feel that why so many different terms that are used, and what is the connection between each one of that. So first thing is that artificial intelligence is a broader area which is addressing, or it is having a aim to bring up all the capabilities what a human has into the machinery. So that's the a major aim of the artificial intelligence. So it is not limiting only from the brain capabilities, but also it would like to utilize any of the capabilities of a human to bring it to machine and create an intelligent could be either in terms of the software, game solving capabilities, or the vision capabilities of the human, or how the navigation the person is taking place, or the robot hand movement. So these are many such examples which are part of the artificial intelligence, which can be thought of as an applications present in the artificial intelligence. Coming back to machine learning is a sub area, basically sub area of artificial intelligence, and which is typically more focused on the learning capabilities, because human have the learning capability. They learn from the given data or the historical information. They utilize that one for the further on. So that's how the machine learning is related. So if you focus only on the learning capability, and then those capability you want to bring into the computation world, that is what the machine learning is. Now, again, deep learning, if you take a look at it, it is again part of the machine learning. That's how the again learning word is coming into the deep learning, more focused on the how human brain is functioning and how it is able to do the its learning capabilities. Okay, that's how all three of them are related, and the year in which they are started also have been plotted here, and you can see that it is the newest one is the deep learning model itself. As I mentioned, the biggest area is the artificial intelligence. Okay, because of this biggest area, you can see many of the techniques which are part of artificial intelligence are also part of the machine learning, and then deep learning is also consist of some set of math technique which are part of the artificial intelligence. So there are several overlapping type of techniques and the application you can see in the real world. Okay, and the main objective of all these techniques is that create an intelligence. Okay, when you take a look at learning capability, you want to take historical information and create an intelligence system which is able to perform the decision, which is able to perform the forecasting, or which is able to perform some identifying some kind of a pattern. So that are the capabilities which we are bringing in from the artificial from the intelligence, human intelligence, into the artificial world, and then providing the better computation and making the judgment in a much better way. So that's the overall objective of all these such type of techniques. Now, coming back to the understanding that what is the difference between the ML and DL, specifically if we are looking at it, because both are learning technique itself, both they take a input data or the historical data, and then they will learn. Okay, that are the capabilities both they have. You must have seen that machine learning have it has tremendous many applications. Okay, and again, DL also having the capabilities of learning from the given historical data. So it can have the capabilities to learn and then go for providing some kind of prediction or identifying the pattern and providing the decision later on. So what is the difference? The key difference lies in an extra additional step that is present here, that is called as feature extraction. Now, feature usually this is the different steps that are taken place in the machine learning. If you are providing an application in terms of the machine learning, there is an input given to you, and various features of an input are identified, and a typical classification is carried out here, and the whether the given object is car or not a car is identified at the later stage. So this is the last level where the decision has been carried out. Now, one of the most important part of it is the identification and recognizing the type of feature you want to use it in the classification level. Now, what are these features? So, for example, very simply saying that if I want to create an application which can recognize the different object, especially one type of car to the another type of the car. So, suppose you want to build in such an application. Now, each car has its own feature, like the type of the model of the car may be having their type of the mirrors are different. The headlights may be having a different shape. Those are creating a different shape. The length of the glass, the windshield that is present on the front, those are all creating the different features of an system. So image can be given, the car image can be given here, and the feature distinguishing features are created, and that are part of the classification. Now, your classification success totally depend on the best quality feature. The better the quality of the features, your machine learning have the higher accuracy, have a higher capabilities later on. Now, difference between the machine learning and the deep learning is that you don't need additional feature extraction technique, or separately it is not required. In the deep learning itself consists a part of one part of it. It is called as performing the convolution operation and creating the feature extraction. Both together, the classification and the feature extraction will be taking place together in the case of the deep learning. And then deep learning can also perform the same type of action, that is the classification. Now, what are the different type of features you have visited? So now here you can see for the text, so you can see this is a bag of word is one such example. And we can also see hog type of features, which are mostly used for image classification and image recognition identification tasks. Bag of word are used for the text classification, and there are various different type of features. Again, the features are specific to the application and specific to the problem domain. So if you change the type of problem you are working, so you have to change the type of features, and the extraction process has to take place. So this is more like a very much specialized on a particular type of the domain, and they can perform well only on those type of domains. So if you change, then you have to change the feature extraction technique also. Now, on the other hand, what you are creating in terms of the DL, there is no external feature extraction technique, but both the feature extraction as well as the classification learning process together will take place in the form of the deep learning. So usually you don't have to worry about what type of features you have to extract, and you have to change those type of features or not, but the automatically it will carry out both the learning part as well as performing the classification. So it is consisting of multi-layer architecture. So usually the initial layers are used for feature extraction. We will even see later on the different type of architecture we are seeing, and then we will list it out that various low-level features are extracted at the initial level, and the high-level features are extracted at the later on. So this is automatically taking place. You don't have to worry the data representation or the feature extraction in the case of various deep learning techniques. So that's the advantage of going for DL technique. So this is, again, it is been listed here, the difference between deep learning as well as the machine learning. So you can see the images, same type of images can be part of both the machine as well as deep learning techniques, but the different steps are incorporated in the machine learning, pre-processing or feature extraction and feature selection, and finally you will have the classification at the last stage. So that is how various steps are present in machine learning. And in the case of the deep learning, you have a complete one architecture, and all the other aspects, okay, whether it is part of the pre-processing or whether it's a part of feature extraction, all of them will be taken place within the single model. Okay, so that's why the deep learning are more famous, because of automatic way of representing. So you can have a best feature automatically identified by the model, and it learns for itself. So that's how the models are working, and they are very much famous. Now, they have the ability to enhance the human life by providing additional diagnosis. So there are various different application DL have been applicable. So one of the examples, like a natural disaster, you want to identify discovery of the new drug, cancer diagnosis. These are some of the example. One of the newest application of DL is in 2020, especially when the COVID-19 has broken, and there are many people have suffering from the COVID as well the chest congestion. Now these chest congestion can be identified with the help of the X-ray images. Now X-ray images will indicate whether there is a chest congestion is present or not, what is the severity of the COVID symptoms, and so on. Different applications have been formed, and one of the, I will give one of the example of Nature publication. So this is a scientific reports that are published in Nature publication of using the deep learning. Now this is a very highly cited and highly useful uh, research paper where the deep learning model has been used for the COVID-19 CT scan images. Now this is the kind of model they have built. So this is the architecture they have given, and these are the different CT scan images. So CT scan images are taken and they are fed into the CNN. Now, based on the different categories of CT scan images, the model will be trained, and it will learn to identify the various categories, normal, whether there is an infection is present or not present. So these are the different type of infection that is present in the images are identified. Once the architecture is trained, now you can submit the unknown image, and the CNN model will able to perform the same tasks and then provide the decision. And you are now no need of further assistance from the external help or the expert here. Only the CNN is good enough to categorize the given test image in terms of whether there is a COVID infection is present, or what is the level of infection that is present, and so on. So this is a best practical example that the DL has been applied in terms of identifying the COVID congestion in the chest, etc. And deep learning, there is a one very good statement that deep learning is going to be able to do everything. Now, why it is these kind of a statement it is told? The basic idea is that whatever human can able to understand and learn, and by learning they can do the various tasks, the same thing can be done with the help of DL. So you train that model, you make them to identify what you want to be done by the model, and they are very good at it. Once they learn to carry out their task, then they can able to do the same task without the help of any external being there. So that is the capabilities of DL. And even then the architecture is looks complex initially, but the later stage, once the model is ready and up and running, the complexity is just a feed forward following the various paths. So that's it. Whenever you are using it for the practical application also, you can use the DL in a much better way. So that's why these are called as universal learning, and they can approximate any given function. So that's the kind of treatment they are receiving. Robustness is usual. You can have a data with a particular loss, or the some kind of a fuzzy data, or there could be noise present in the type of the data, and then you can use the deep learning, and then they are able to perform their decision in any given circumstances. So that is the robustness of these type of techniques. Now, various areas in which the deep learning have been applied found very good applications. Now, we will just broadly see that where are the cases in which the deep learning have found the application, as well as where is it is better to look for the deep learning solution. Is it, if you are solving any kind of application, is it the better for you to go for a deep learning and then apply that and give the better results? Now, some of the examples are here. So if you are looking for if there are no experts are available, then you can go for the application of the deep learning. You make it to learn what you want to do, and then it will exactly carry out its action. Now, sometimes it is very difficult to explain the decision. Okay, why a particular expert take a particular decision. It is very difficult, especially in the case of medical decisions that are made, or the speech recognition, the complex language understanding. So these are the areas where you cannot explain why a particular decision is being made. In that case, you will apply the deep learning, and then the deep learning will understand based on the given patterns. And once it understood the pattern, once it has learned the given patterns, then it is able to perform the task in a much better way. So that's how you can see that the cases where the DL is more applicable, and various ways where the in time the problem and the problem domain itself require some kind of an updation. The best example is stock market prediction, weather forecasting, because continuously data is changing in these kind of fields. So you could be having a continuous data that are coming up, and then you can perform the prediction and then go for understanding their decision. And the cases where adaptation is based on a specific cases, personalization, biometrics are some more examples where deep learning have been used. One more area of newest application is sentiment analysis, market watching, feedback of the reviewer, customer reviewer analysis, and so many other areas in which the deep learning have been successful also. And you can look forward for applying these deep learning, especially in these type of cases. Now, coming back to the type of classification approach, especially in the case of deep learning, we can divide the deep learning approaches in terms of three categories. One is called as unsupervised. Second one is partially supervised, and the third one is completely supervised. So these are three different approaches which are present in whenever you are training the given deep learning. Now, first one, we will see what it is supervised, because it is easy to understand that. In the supervised case, it is just like a learning using a teacher. So a teacher is known about the subject, so he or she knows about the entire subject. Then there are labels which are present acting like a known information. So for example, these are the images of cats, dog, and chickens, which are indicated by their labels. So this information is already present with us, and this will create what it is known as training a supervised way. Now, DL will use these label data and learn on the given data. So this is called as supervised way of learning, because already some information is already present with us. And once the DL has learned, you can use this particular learned DL in order to make the decision related to unknown images. So suppose unknown image comes, DL is able to perform its action and identify the label. In the case of unsupervised way, we don't know the type of label. We have a list of data over here, but the characteristic of the data is matching. For example, here, this particular data characteristics are matching over here. And another type of characteristic of the data they are matching. And in a sense that you are able to perform a kind of grouping, or there is a characteristic difference between one type of data to the another one. In that case, you can apply the unsupervised way of learning, and these neural network are able to perform the what it is known as clustering of these particular data. So this is a model which will apply the applied on the data and created different type of cluster. The third type of model, which is now becoming very much popular, especially because huge amount of data which is unlabeled. The data is partially labeled, and many of the data which is kept present, but it is being unlabeled. So one of the technique that it is called as partially supervised, in the sense that you initially utilize the existing data, that is this part of the data which is labeled, okay, and then go for applying the DL technique, and the DL technique learn on the given smaller data and can perform the classification. Once it started performing the classification, the unknown unlabeled data is fed. Based on whatever the information it has, it will perform the classification. Now, this is the kind of classification the DL initial level of DL is created. Now, this particular data is again fed to back and used to go for the training. Okay, so you have increased the level of the training here, and then again you can go for the classification on the increased data set. So there are several iterations you need to make it in order to make a complete and better classification in the case of partially supervised. But the partially supervised are now becoming more famous because the lack of labeled data, and you may be having a few labeled data, and then you can start working with the help of partially supervised learning technique. And this technique is possible. First one is unsupervised, as I already told. And what it is required in the case of unsupervised is that there is a significant difference between one type of data towards the another. Some of the examples of unsupervised is Boltzmann machines. Autoencoder is another example where you don't need labels. The machine itself able to identify the pattern and create it. RNN, GAN, these are some of the examples where the unsupervised technique can be applied and the model can be made to learn on the unsupervised way. Now, what are the applications of these? You can go for clustering. You can identify the various distribution. The dimensionality reduction is one more very good example of creating these cluster and reducing the overall data to the smallest one, and then later on you can perform the classification. Now, various applications are exist in the unsupervised way. Coming back to the different type of model, what we were looking at, recurrent neural network. So initially what we were looking at the type of architecture over here. So started with understanding. So one of the other type of architecture is the recurrent neural network. In the recurrent neural network, the idea is we want to use the data which is interconnected in the sense that it is being implied somewhere from the previous information. Some examples are the stock values. Stock trends are actually not independent, but they are influenced by what happened to the previous values. And the previous value is usually influenced by its previous value. So there is a kind of chain of connectivity of the data is present, and that's what we call it as a sequential data. So in order to learn and create a meaningful pattern on the sequential data, there is one more architecture that is called as recurrent neural network has been developed. Now, this is an example of recurrent neural network. It is consisting of multiple layers, and then you have one connection from the previous layer connecting previous output connecting as an input to itself. We will further explore about the recurrent neural network, its application, as well as the advanced LSTM architecture of the recurrent neural network in the forthcoming slides. We will more focus on the convolution neural network at this stage, and then we will go for recurrent neural network later on. CNN stands for convolution neural network, and this is a typical architecture of the CNN architecture that it is being shown. It has found various applications starting from computer vision, mainly into either 1D data processing or two-dimensional, or as well as a three-dimensional data processing. So mainly they are applied on these type of data. Face recognition is again another example. And what are the constituent part of an convolution neural network? Let us take a typical architecture. So this is an example that it is given. Now you can see that there is an input image that is present over here, and there is a convolution layer which will create feature map. Initially, when we will think about learning pattern, the convolution layer creates the pattern, understand the pattern, and create the feature map inside itself. And then ReLU, the different type of layers are incorporated over here, such as ReLU, polling, and then this will increase their capabilities. And later on, at the last stage, is a fully connected layer. So in the fully connected layer, all these layers which were part of in terms of a matrix form, they will be expanded and kept in terms of a one-dimensional vector, and this will be vector will be fed into the fully connected layer, and then the fully connected layer will perform the final decision action. Now this is a typical architecture. Now we will briefly go and understand what are the part of the given input, and if the given input is present, and how it is processed, and how the internal operation inside the convolution neural network itself take place, and what are the kind of manipulation take place at the end it is able to perform its action. So usually we have different layers. Okay, so we have a different layer as it is given. So we can call this one the input image as a X convolution layer, consisting of the matrix of different filters as well as the different operation that take place. And the image we will call it as having a different depth. So usually the colored image will have a RGB values, and they are called as a different channel. So having a R depth, and a convolution layer usually have several kernels. So these are also called as filter, and these dimensions are typically created in terms of n into q. Q is either exactly same as depth of the image, or it could be dependent on the what type of application you are solving. So n it must be smaller than m, so because m is standing for the size of the image, and r is standing for the number of channels that are present in your image. So while q is either, so this could be q is either equal or smaller than r, depend on what type of application you are using. You can select the different size of the kernels. Now, usually the kernel, each filter or the kernel has some weightage. So it is nothing but consisting of the bias as well as the weight values. And those weight values are utilized in order to create the feature map. Okay, so the feature map at each one cell of the feature map is represented in terms of HK, that can be computed by taking the weighted summation of the given input value plus the bias that is present, and then applying the activation function over here. And this is how the feature map is created inside the convolution operation. Further on, an example of the convolution operation, filter operation, has been shown over here. Now, this is the kind of filter that is present, and you can have a typically an input image has been shown over here. So it could be off size treated as m by m here in this case, and n by n is the size of the filter. Now each cell is multiplied with each one and another over here, at it is shown over as an example, and then followed by that you will obtain the value of this particular cell based on by taking the summation of all of these cells. So this is a typical convolution operation that it is taking place inside the convolution operation. Now, next step, usually after the convolution, usually like here, what it is shown, the usual like what we get is the biggest size data. And the next step, what we want to do is we want to reduce the number of parameter, the number of features that are present. So in order to generalize and stop overfitting, if at all, any possibilities. So in order to achieve this one, there is one more operation that is being followed inside the CNN architecture. It is called as pooling function. So pooling, there are two type of pooling function typically are applied. One is max pooling, and another one is the average pooling. So these are some of the ways of identifying the best values within the given filter outcome. And at the later stage, we will apply the fully connected layer. It is also called as FC layer at the end, which utilizes the existing features after performing several times the convolution as well as the pooling and normalization, different type of layer application on the given data, and the refined data will be fed into the fully connected layer, and the fully connected layer will able to perform the classification at the last stage. Now you can think of that the final classification and the decision will be carried out by the final FC or fully connected layer in the given CNN architecture. Now, it is typically the convolution neural network consists of filter. It is also called as kernels, or they are also called as convolutional filters. Now, what are the benefit of applying these convolution filters? One thing is that you don't want to introduce the human interpretation of the given image and understand and then go for feature extraction. Can it be done in an automatic way? So that can be achieved only with the help of the convolution filter that are part of the given architecture. Now, by using the convolution filters, what you are doing is you are avoiding the presence of any feature extraction external step that is part of the usually machine learning steps, but the automatic way of feature representation you are creating. Now, these feature convolution operations are designed in a such a way that the initial weight values are assigned in a random way, and as the learning takes place, these weight values will be adjusted. These weight value will be adapted during the weighting process, and the kernel will also able to adapt itself for the best possible decision that would take place at the final fully connected layer. So that is how the interdependency is present in the complete convolution neural networks. The final one what you want to achieve is the fully connected layer. That is what it is giving the error back propagated, and those back propagated errors will be utilized to update the various weight values that are present in the convolution layer also. Now, this is how you can make most optimized feature representation. They are useful for the classification purposes. Now, usually you have a different channels. Now, what are the different channels? How do you achieve the different channels outcome? It is based on applying the different set of kernels. Okay, you could have one kernel or two kernel or multiple kernels. So you based on each one kernel, it is giving you different features. Okay, each feature will create a feature map, and the entire set of feature map can be utilized for the complete classification process. One example has been shown over here. You have an input layer, and then followed by that you have multiple number of convolution operation that is being can be carried out over here, and then that can be achieved with the help of proper filtering, and then you will achieve the different set of convolution outcome over here. So these are the different feature map that are automatically created with the help of different set of kernels. And going further, there is a one very interesting operation. It's called as pooling operation. The idea is creating subsampling of the feature map. Now here, this example shows how the pooling operation take place. You have bigger dimension data after performing the convolution. Once the convolution operation is performed, the weighted value between the feature map, the kernel values, and the image is being created, and then the complete feature map has been created over here. Now, many of the time, what problem with the feature map is it may be representing the given image, but it is not generalized the way of representation. It is consisting of more number of samples, which are not essential whenever you are creating the complete entire neural network. So thereby, what we are looking at is to create a kind of subsampling in order to increase their generalization capabilities. So an example is shown here. A small part of it is taken over here, and then the subsampling is created. There are various type of pooling. One is called as average pooling. There is a max pooling. There is a global average pooling, max global average pooling, and so on. Depending on the application, you can choose the pooling, and these are the examples. So basically, you take a subsample of the given feature map, apply the pooling over here. For example, here this particular area is taken, and the average of this value will be placed on a single cell, rather than this big particular 16 number of cells. You are now reduced to only 4 number of cells in the after performing the average pooling. Thereby, you have actually achieved the subsampling, and then going for a reducing the total size of the feature map into a smaller way. Now, another benefit of going for a average pooling especially is that it can avoid the noise that may be present after performing the feature mapping. After performing the various convolution operation, there could be presence of the noise that can be reduced with the help of the average pooling operations. Now, at the end of all these, we will also use the activation function. The objective of activation function is to introduce the non-linearity, and thereby there is a capability of learning, and the feedback creation is possible, feedback backpropagation possible in the artificial neural network. So this is a typical neural network consisting of single neuron, and this neuron consisting of taking the summation of all the input values multiplied with some kind of weights over here, and finally applying the activation function. So this activation function, there are different type of activation function creating different ideas in the different patterns, different distributions within the given problem domain. So you have different type of activations present in the artificial neural network, and especially they are highly useful. And most of these nonlinear type of activation functions are used whenever you want to employ the back propagation, which is automatic way of learning the given weight values, etc. So that is most useful in that case. Now, these are some of the activation function what we can see typically in the artificial neural network, like sigmoid, leaky, relu, and tanh. So these are some of the most useful. There are many few more. ReLU is mostly used in the case of the deep learning neural network, which is simplified also, as well as most efficient way of computing the values rather than going for the sigmoid or tanh. So these are some of the examples of activation function. Coming back to the fully connected layer, the final layer of your neural network is the fully connected layer. The fully connected layer, the idea is that you utilize the given feature map and perform the final decision based on the fully connected layer. So this is an example of the fully connected architecture, what it is shown over here. Now, there are various loss functions are used. The loss function, the idea of the loss function is that what is the difference between the expected outcome and the actual outcome that it is the neural network is creating. And once you understand the kind of error it is creating, you will propagate it back, and thereby the neural network will be able to perform the learning process using the loss function. So various log function, one of the example of log function is the softmax loss function, or it is also called as cross entropy log function. The idea of the log function is to provide the outcome in terms of the probability. Okay, this is the probability that it is achieved by the loss function, the softmax log function over here. Now you can see this is just an estimation of the outcome in terms of the log function. So we will also use these in order to identify the error that it is created with the expected outcome as well as the actual outcome. Now, regularization is a very interesting part of CNN, especially when you want the neural network to fit in a correct way. You don't want it to be overfitted or underfitted model. You want it to be balanced and correctly fitted. So thereby you will utilize the different technique in order to perform the regularization. What are the different techniques? Now, there are various dropout of the entire neuron itself, which is possible. Dropout of the entire layer itself is possible. And you can stop some of the neuron to learn. That is also possible in the neural network. And drop the weights or the connection that is present. Thereby, you reduce the overall size of the neural network and thereby improve its generalization. The overall idea of regularization is improve the generalization capabilities. And data augmentation is one of the key term that is part of, especially when you have limited data and you want to utilize the deep neural network. So this is an example where you will create the automatic data. For example, you will apply the rotation or translation or shifting of the images and then create the newest data set with the help of the existing data set. That is called as data augmentation. And the batch normalization or the typical normalization process is bringing the data values within the particular range of the given range. So that will improve the again generalization capabilities. Now, optimizer selection. So there is two important steps are required whenever you are using the convolution neural network and training the neural network. One is called as optimizer selection, and the second one is called as the enhancement. Now, what are the optimizer? The optimizer is an example like gradient descent technique, which is applied on the given neural network, and then your neural network is able to learn or adjust the weight values. In order to carry out this particular process in much better and faster way, there are various techniques such as ADA delta, ADA guard, or the momentum. Various different type of techniques are applied in order to enhance the learning capabilities. And this is the example of batch gradient as well as the stochastic gradient. The technique is that the given the loss function you want to reduce, or the error function that is present within the neural network, you want to reduce it to as low as possible with the help of the gradient uh, of the given function, and take a route, and then you will finally come to the very lowest loss of the given function. So this is the idea of the gradient descent technique. Various enhancement techniques are applied along with the gradient. One of the examples is momentum. In the case of the momentum, the idea is that you will utilize the momentum from the previous value and how fast you want to go and proceed and reach to the final center. That's what it is been possible with the help of the momentum. Momentum will be decided what is the previous value, how much you want to continue in the same fast or same pace of the momentum in the previous value, or the how much you want to retain the newest value. So that's the trade-off is possible in the case of momentum technique, and then go for the next learning values. Adaptive moment estimation, also called as ADAM, is another optimization technique or learning algorithm that is widely nowadays used. And this is based on the second order derivatives that are employed in the case of the using the loss function. There are various different technique. The best way to understand and take these technique is that you have to try it out different techniques on the given architecture and finally come to a end conclusion. That's how you can make these adjustment within the architecture. Now, coming back to the type of different architecture, because you can set up these layers and the number of layers in a particular fashion, that itself create a architecture. So one of them started with 1998, that is called as LeanNet. Now, this is the kind of architecture that is shown over here. The LeanNet is mainly focused on handwritten digit recognition. Okay, it is not much scalable. It is fixed, but it is performing the handwritten digit recognition. Next one, most advanced or the most popular one is AlexNet in 2012. So it is achieved the best recognition rate at that moment in the image recognition as well as the classification. Now you can see it is consisting of both a mixture of pooling as well as the convolution layers, which are kept alternatively, and at the final stage you have a softmax classification. And this is performing a very good classification during 2012. And visual geometry group, this is another architecture of the CNN. So this is called VGG, very much useful or much popular in terms of the image recognition. Okay, so this is more advanced than the other type of nets such as ZepNet as well as AlexNet, VGG, and it has created the more advancement by looking at the previous one, introducing the smaller filter rather than going for the bigger one in terms of the resolution and so on. So overall number of parameters that are present in VGC is tremendously, like 140 million parameter in the sense that number of weight and the biases and the consisting of different values which are present inside the architecture, which need to be trained. Okay, so that's the type of next one is a Google Net. Achieving a high level of accuracy is possible with the help of the Google Net at the lowest computation cost. Okay, that's the objective of the Google Net. And architecture incorporate various different size of filter, starting from 5 by 5, 3 by 5, as well as 1 by 5. So this is the architecture that is shown. So you have a different type of architecture, combination of it. You have to train that and then make it working on a given data, and then go for showing it as a one of the best one. A few more such architectures are available. Another one is DenseNet. The best part of the DenseNet or the advancement that it is taken place in the DenseNet is that it is having a cross-layer connectivities. Now you can see that first layer is getting connected from one towards the last one and in between and so on. That is how the dense net has given the more advanced results. Exception and inception are the again extreme inception architecture. So this is the architecture that is shown over here, consisting of convolution as well as the pooling in terms of the different fashion. So one and another one, they are connected with each other. So that's the way of the exception architecture. Coming back to one very important architecture, and our current research was focused on the recurrent neural network. Now, what is this recurrent neural network? Recurrent neural network are able to perform the task something like this. Now, if a question has been asked in the while typing on the Google, you must have seen it is automatically filled or giving some kind of a suggestion. How it is possible? Now, what's the best food to eat in Laos? Because there is a gap that is present. Now, the most applicable word that to be replaced in these dash line is Vegas, because that is the most frequently appearing word whenever you type the word last over here. Thereby, how do we know that that is the most appropriate word to be replaced over here? That is only with the help of the sequence information that is present. Now, once you start typing this information, there is already interdependency and the sequence information is present. Now, this is an example of an sequential data, and in order to process sequence data, you have a recurrent neural network. This is an example of a recurrent neural network over here, and giving you the presence of the word as a Vegas. Now, a little bit basics about the recurrent neural network. Recurrent neural network typically consisting of input, the state of the given neuron as a H, and it is also providing the output Y. That is the Y is the output, and there is some part of the output it is also coming as a feedback or as an input. That is called as the recurrent. Okay, so coming back from the output, thereby it is creating the next level outcome. So usually you have dependencies written in terms of the timeline. So this is the timeline where you are standing. Now this is your timeline where you are standing, and the output of this particular value is dependent on the previous one, and the next value it will be consumed by the next present value, thereby creating a kind of a chain action. Again, you will have your own input also, and along with it you are also taking the previous values also. So this is how the recurrent neural network works. Now, why the recurrent neural network is essential? Can we incorporate convolution neural network for all of the operation? Now, there is a typical operation. Yes. How much time is there?
Doctor, I'm so sorry cutting you in middle.
Uh-huh.
Sir, I guess we have up or concluded. Because our next speaker, Dr. Gangadhar Iluru, is already joined us.
Okay.
Yes, sir.
Can I briefly complete our research area, what we have completed? If I have 2 minutes.
Sure. If Gangadhar sir has no issues.
Yeah, because
yes. I'm Dr. Gangadhar. I don't have any issue. Sir, you can take your time and complete it.
Yeah, because I just come to the recurrent neural network. Yes, the next one is the LSTM. That is what we have focused on our research. And going fastly, I will focus on our results. What we have worked on is the multivariate data and utilizing both the LSTM and creating a different type of architecture. The idea is that there are various data is collected and going for oil price prediction. The data between Jan 4, 2000 to 2009, 20 years data has been collected, and various dependent variables also are obtained. Now, this is the kind of data that is present over here. And what we have done, so this is the distribution of the oil prices, and this is a box plot representing the oil prices over here. Now, the idea is that we will utilize the Mahalanobis distance and integrate it with the LSTM. So that's the what we have presented in terms of the research outcome. And because of this kind of integration, we are able to create the architecture of LSTM, which is giving us much better results. Okay, rather than going for single LSTM, with the integration, we could achieve the best results. So firstly, for moving forward, this is a kind of architecture what we have created. So there is a data acquisition take place, pre-processing, and then data transformation using the Mahalanobis and so on, and building the data final model with the help of LSTM over here, and then the final results are present here. So this is already published. You can look into this particular paper. And these are the some of the results. So various different architectures are created with a small difference in the presence of Mahalanobis or Z-score transformation along with the different type of features. The best part is that we could able to achieve a very high accurate result. Now you can see that our RTZ, the final one, is giving us 0.95 R square error, so the highest one in terms of the regression model. Now, what the overall presentation was to you incorporate various advanced technique in the deep learning, so that it will give us very good results. So that's the main objective of my presentation, today's presentation. So I just stop the screen. So if you have time or anybody having a questions or any kind of suggestion are most welcome.
I will also request attendees if they have any queries, they may please put it forth in the chat box or unmute themselves, ask directly. Meanwhile, our team will also have a consolidated report from YouTube as well, if anyone from there has any queries. So I will proceed further in the interest of time, Dr. Siddaling. And I would move to the segment of vote of thanks for your amazing session. And it was really powerful session. I'm so sorry I had to break you in middle. Because of time constraints, because there was a session after session after session.
Yes, I can understand
but then it was an amazing session, sir. I could also learn a lot of new things regarding LSTM, RNN, and how these newer architectures like Google RNN and all that, Google Net and all, how they're actually really helpful and how we can build upon them. So that was really amazing sharing and amazing contribution of your research particularly, and also to spread it across so that we can also get inspired from your research, your work, and we can also build upon that. So thank you very much, Dr. Siddaling. It was an amazing session, and I will request my team to please present memento to our esteemed speaker, Dr. Siddaling, for his valuable contribution for this particular consortium. Team, are we ready? Okay, I guess they will be sharing it, sir. So meanwhile, I will move ahead, and I will also thank our esteemed mentors, without whom we would not have been achieved this place. So Dr. Rajeshwari Hegde and Dr. Susan Elias, because they have helped us in each and every path of our lives, how we can move ahead. They have always supported us, so I would like to thank them. Esteemed thank and a hearty thank to each and every organizing team and collaborators for their efforts, and and I will also like to thank our sponsors, Verivo Motors and EduCheck, for having a faith in us and the belief what they have shown in us, and each and every audience who are here. So quickly, we will be moving to, within a minute or so, we will be taking us to a goal and a goal setting for a research outcome, so that we can that basis. So within 2 minutes, we will be starting that particular session. Stay tuned with us.